do some of these problems so that you can do this on your own time when you want to hear it. But if we're going to convert this to scientific notation, we need to move this decimal, and we need to move it so there's only one number to the left. So that means we're going to move it two ways this way, two spaces. And if we move that two spaces, we get 7.9, only one number to the left. And since that original number, the 0.0079, oops, how about 0.079, is less than 1, we want to make that a -2. So that was two jumps, and because that original number was less than 1, that exponent's going to be a negative. For this one, it's going to be positive. We're doing two jumps this way toward the 8, so we get 8.41. There's only one number to the left of the decimal, and those two jumps are represented with a +2 because 841 is greater than 1. Standard notation for this, 4.6. We're doing four jumps, and we're trying to make it less than 1, so we're going to go this way, and it's four jumps. We put some zeros in there, so we have as an answer 0.03046. Okay, standard notation for this number, 5.13. We're doing jumps to make it a larger number because that's a positive exponent. So 5130. If we're going to take the product of 10 to the 7th times 10 squared, we're going to add the exponents. So it's 10 to the 7 plus 2, which equals 10 to the 9th. This is number 6. If we're going to divide 10 to the 11th by 10 to the 5th, we're going to take 11 and subtract 5, which is 10 to the 6th power. All right. Multiplying again, 10 to the 3rd times 10 to the -5. So it's 10 to the 3 minus 5. We're adding them, but since that's negative, hopefully you remember that from math, that adding a negative is basically subtracting, I guess. So that comes out to be 10 to the -2. These we're subtracting, so it's 10 to the 6th minus 10 to the 10th, which comes out to be 10 to the -4. So for this next one, 2.7 times 10 to the 4th times 8.6 times 10 to the 3rd. So I'm going to show you how to do this on a calculator. I'm going to use just the Google calculator. So 2.7 times 10 to the 4th. So a couple ways to do this. You can just do 2.7 times 10 raised to the power of the 4th, which would be this button. And then I'm going to multiply that times 8.6 times 10 to the 3rd. 8.6 times 10 to the 3rd to the 3rd. Enter. Okay, so there's my answer. Now I need my answer to be in two significant digits. So even though this is my answer, I can't, as many of you did, and this is a common mistake, which is why I have my spiel already ready. I can't replace this with 23. So just there. Oops, never mind. All right, so the number I just got out of there was 2. Forgive me, kids. I'm an old man. All right, 2, 2 twos, and then 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5 zeros. 2, 3, double 2, and 5 zeros. All right, so here we go. 2, 3, double 2, and 5 zeros. So if I owed you that much money and I paid you $23, we would not be equal because I did not pay you back anywhere near the magnitude of what I owed you. So when you're converting this to two significant digits, what we're going to do is replace these two with insignificant zeros. So 2, 3, and then a bunch of zeros is the answer we wanted, because now that is a little closer in magnitude to the original number. This is not the way to go. All right, so ideally you put either that, or if you put that in scientific notation, 1, 2, 3, 4, 5, 6, 7, 8, it would be 2.3 times 10 to the eighth. So both of those are fine. Another way to do it is, I actually think, anyway. All right, so the other way to do it would be 2.7 and then which is the exp to the fourth, times 8.6 times 10 to the third. 8.6 to the third. So that means times 10 to the, that means times 10 to the. Then you just hit equals and it gives you the same answer. All right, and there is a button here that makes it go back to scientific notation. I just don't know where it is. Anyway, all right. So next problem, 2.06 times 10 to the 14th. So we can do that 2.06 exponent 14, and that's divided by, oops, that's divided by 4.61 times 10 to the eighth. So 4.61 exponent 8. So you hit that and you get this answer. Now we want that rounded to 3 significant figures. So 3 significant figures is just these 3. So we want 4, 4, 6, and then a bunch of zeros. You would actually round that 6 up to a 7. So 4, 4, 7, and then 3 insignificant zeros after that. So the answer there is 4, 4, 7, and 3 insignificant zeros. Which could also be put in the form 4.47 times 10 to the 1, 2, 3, 4, 5, right? 10 to the fifth. So either of those would have been acceptable. This is the one where you need the parentheses. So if you're not going to use the E, if you don't want to use that E, then 2.06 times 10 to the 14th divided by, now that second number needs to be in parentheses. So 4.61 times 10 to the eighth. 4.61, oops, I just didn't do what I told you to do. Put that in parentheses. 4.61 times 10 to the eighth. That needs to be in parentheses because now it won't just divide this number by the 4.61, it'll divide it by all of it. And so you will see, actually, let me copy that, see if that works. Okay, so there's the same answer we had before, right? 4.47 times 10 to the fifth. If, however, I do the other thing, it's not enter. Okay. I guess it won't let me paste that before. Okay. So if I didn't put those parentheses in, the point of all that is that if I didn't put the parentheses in, 2.06 times 10 to the 14th, 2.06 times 10 to the 14th divided by 4.61 times 10 to the 8th, 4.61 times 10 to the 8th. So what you'll see here is that it's just going to divide by the 4.61, and I'm going to get a much larger times 10 to the 21st. And that's not the correct answer. It should not be times 10 to the 21st. It should be by 10 to the 5th. So it added my exponents instead of subtracting. All right, so this next one, 8.41 times 10 to the minus 3. 8.41 times 10 to the minus 3. And that's going to be divided by 7.07 times 10 to the minus 6. Divided by 7.07 times 10 to the minus 6. So I already just messed that up. 7.07. Oh, I didn't have to do this, right? Because I'm doing this. minus 6. I didn't need parentheses because I was using the E, but anyway, I fell asleep there. 1.189, so that would be, how many significant digits did it need to be? 3. So that's 1.19 times 10 to the third. This is either 1.19 times 10 to the third or 1190. Either of those are acceptable. The last one is 6.32 times 10 to the 12th. So 6.32 times 10 to the 12th. So you can do these with the E or without. Oops. Parentheses will be helpful. 1.90 times 10 to the minus 4. So 1.90 times 10 to the minus 4. Enter. All right, so that's the number I get. That's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1.2 times 10 to the ninth, but it wants it to be in 3 significant digits. So 1.20 times 10 to the ninth is the best way to do that.